What makes a piece of software high quality? Some people might say it needs to have lots of features. Others may say it needs to be extremely reliable, something that never crashes. And others still might say all you need is a slick UI with satisfying animations. Don't let that third group near your dev team. But for most people, security isn't usually the first answer that pops up in their heads. Security has always been relegated to stepchild status, an afterthought that's bolted onto the end product to get it to pass some compliance regulations. In reality, an application that performs all its intended functions well cannot be considered high quality if it doesn't also operate securely. Every microservice, every container, every last API can drastically affect how your application processes user data, opening up new channels for bad actors to sneak in and wreak havoc. How then can security not be a part of the intended experience? To quote this report by CISA, security is not a luxury option but is closer to the standard every customer should expect without negotiating or paying more. To that end, a secure application isn't one that has security features added to it at the end of the build, but one where the controls are baked into the product all the way from design and development to deployment and production. So let's talk about the secure by design philosophy. A product that's considered secure by design is one where the security implementation is deeply enmeshed in the structure of the software, where a lot of planning goes into finding and fixing vulnerabilities at the earliest possible stage. That could be performing a static analysis scan before each build to check the source code, or analyzing the list of third-party components for insecure libraries, or testing the app during runtime with DAST. Each of these confer their own benefits, but when these activities are performed as part of a CI/CD pipeline, where every step feeds into the next, the resulting stream of useful security data can not only make it easier for the developers to fix pressing security issues, but allow the security team to give actionable feedback. Over time, incremental improvements in the pipeline can make for serious gains in efficiency, improved documentation, and most importantly, a much more secure product. Secure by design is not to be confused with secure by default, which refers to a product that is secure out of the box and doesn't need to be configured by the customer. That means implementing controls like single sign-on, eliminating default passwords, etc. We won't be talking about that here. So let's look at some secure software development practices as recommended by CISA. First, it helps to conform to a secure SDLC framework. It's hard enough to implement consistent security controls across your environment, but to do so without an established set of security guidelines, you're doing a lot of extra work for no reason. Identify a secure SDLC framework that lays the groundwork for you by showcasing secure development techniques, actionable inputs, and security best practices that your developers can follow. These need not be strict rules, but instead useful guardrails to help keep your team on track. Next up, manage your vulnerabilities. One of the most crucial parts of secure development is figuring out how to deal with vulnerabilities. Automated scans result in a ton of false positives. Some vulnerabilities may show up in the results, but would be completely inaccessible to an outsider and therefore not dangerous. If you fail the build every time an old vulnerability appears, your developers will just get annoyed and quickly lose interest in doing anything security related. Use something like a vulnerability correlation and aggregation tool to take in all your scan data, where it'll analyze each vulnerability, assign it a severity score, and prioritize them based on how serious they are. Third, be extra careful using open source components. Third-party components are a common and necessary part of building software products today. After all, when there's libraries and databases for almost everything, why bother building them on your own from scratch? But using third-party software can introduce its own set of security risks. From nested dependencies having vulnerabilities you could never anticipate, to package managers installing the wrong or malicious components, your software supply chain is fraught with danger. Maintaining an up-to-date software bill of materials or SBOM is imperative to performing source composition analysis. This is going to help you identify insecure components and update or replace old and outdated libraries. On to number 4, provide secure defaults for developers. There's a concept called the paved road in software security, which talks about creating a set of default security controls and protocols that are not only secure but easy to adhere to. You can't expect developers to be experts in writing perfect, always secure code. You also can't just give them a laundry list of all the problems in the build and expect them to fix all of them with zero guidance. If they don't know what to do, they'll just choose the easy route, one that's probably less secure. Reduce the cognitive load on your developers by making the easy solution the secure solution. In other words, pave the road for them so it's harder for them to choose the insecure option. For example, you could identify a set of well-maintained libraries you know to be secure, or offer tools and services that automatically lint the dev's code within the IDE itself, so issues can be resolved super early. If done right, secure defaults can help you eliminate entire classes of vulnerabilities, massively reducing the effort you'll need to put into fixing bugs with each subsequent build or sprint. At number 5, you should train your developers in security. Your engineering team doesn't need to be the SEAL Team 6 of security, but they ideally should be familiar with the broader principles and best practices of creating secure software. The best way to do that is through training that doesn't just teach them, but engages them with hands-on learning. AppSec Engineer has a massive library of courses, hands-on labs, and challenges for every member of the product team, including developers. Our courses take them through real-world security scenarios where they have to compromise an insecure app, identify where the vulnerability lies, and fix the issue. We even have language-specific playgrounds where you have to find and fix bugs in apps written in Java, Python, Ruby, Go, and much more. Next up, create a threat model of your apps. Threat models are like a security blueprint for your software. They help you understand the structure of the application, how each part fits in with the whole, and where you can expect to see security threats emerge. A high-level threat model can help you better design your apps, plan out security activities for each stage of development, and anticipate security risks before they even come to pass. And finally, implement defense in depth. One of the biggest advantages of containerized microservices-driven software is how they all communicate with each other without being completely dependent on one another. You should design infrastructure so that even if a single security control is breached, it doesn't result in the compromise of the entire system. For example, ensuring that user privileges are narrowly provisioned and access control lists are employed can reduce how much damage a compromised account can do in your cloud. Additionally, software sandboxing techniques can quarantine a vulnerability to limit the compromise of an entire application. If you want to learn more about developing software with Secure by Design principles, you don't want to miss the Secure by Design Across the Stack webinar by Abhay Bhargav. Join us on 25th July at 9 a.m. Pacific time for an in-depth exploration of building software with security controls baked into the very heart of your application. Explore the Secure by Design principles promoted by CISA and how they can be applied to enhance your security posture. Learn how to integrate security principles across various layers of your application stack from the front end to the back end, and discover industry best practices and methodologies for building secure applications by design. Register now with the link below and learn how to vastly improve your organization's security posture with the help from the industry experts at AppSec Engineer.